So here we're going to talk about naming the ionic compounds where we're dealing with a transition metal that can have more than one charge. Because it can have more than one charge, we have to actually specify what the charge is in the name to differentiate the different transition metals. For example, if we just said copper oxide for this, we wouldn't know, is this copper plus 1? Is this copper plus 2? The name wouldn't tell us anything. So let's go ahead and determine for this chemical compound which copper we have to use for the name. So because the copper can have more than one charge, we can't start there. We've got to start with the negative guy. The negative guy only has one charge, and for oxygen, we know it's always -2. There is one oxygen here, so 1 times -2 means that there's a total of -2 charge in this whole ionic compound. Well, we know the overall charge for the ionic compound has to be 0. So what has to be in that box? How many positives do we need to make this statement true? Well, it has to be a +2. +2 minus 2 equals 0, right? But we have two coppers here. If it helps you to draw it out, copper and copper. That +2 has to be shared over the two coppers, which means each copper gets a single plus charge. So the copper that's here is actually copper plus, okay, +1. So to name this, we will name the positive cation, and that positive cation, remember, is copper with a parentheses, Roman numeral 1. So this is copper, parentheses, Roman numeral 1. And then we name the negative guy, happens to be oxide, the IDE ending. Let's do another one. This time let's do CuO. Well, that's copper oxide too, right? No, it's very different. And let's see why. Again, we're going to start with the negative guy. Oxygen, we know, is always -2. There's one of the oxygens here as well. So we're going to have a total of -2 for all the negatives in this compound. Now, we know the whole thing has to equal 0. So then what fits in the box to make this statement true? It has to be a +2. That +2 has to go over one of the coppers. So we don't have to divide it among the two like we had to up here. That +2 goes totally on that one copper. So in this case, the copper gets the +2 charge. So this is now, we name the positive guy. The positive guy is copper, parentheses 2, oxide. Okay. So clearly, these two compounds, very different. They're going to have different properties, copper 1, copper 2. Okay. Let's work on a couple more examples to make sure that we have this clear in our head. Let's go ahead and do iron. Remember, iron is abbreviated Fe. And the iron can be +2 or +3. So again, we can't just name this without figuring out the charge on this guy. Well, we'll start with the negative guy. Oxygen is always -2. There's only one of them, so we've got -2 is the total number of negatives in this compound. They have to add up to 0, so what's in the box? A +2. There's only one iron here, so the iron gets the entire +2. So we label this iron 2 oxide. And let's try this other one. Here we've got iron 2O3. Again, we'll start with the negative guy. The negative one is oxygen, and it's a -2. And this time, we've got 3 of the oxygens. So we have 3 of the -2s. So the total number of negatives in this ionic compound is minus 6. Whole thing has to equal 0. So what is the positive? Positive has to be plus 6. So we got to be careful because we have 2 irons. Again, if it helps you, draw the 2 irons out, iron and iron. They have to add up to total plus 6. So each one has to have what plus charge? Well, this one has to be a plus 3, and this one has to be a plus 3, because they'll be the same. The iron, therefore, has the plus 3 charge, so when we go to name this guy, it would be iron, parentheses, 1, 2, 3, close your parentheses, oxide. And that's basically how you're going to name your ionic compounds when you're dealing with a transition metal that can have more than one charge. And if you want to use the older names, cupric, cuprous, ferric, ferrous, that's fine too. But also make sure you know the systematic way of doing it. Don't forget Roman numerals and the parentheses.